Hello guys, welcome back to my channel. Today we're going to look at Cambium Networks. They claim to have made a long distance link with 245 kilometers. So that's what we're going to check out, and stay tuned. We're going to have a look at this network connection Cambium Networks has done in 2015. They've made 245 kilometers from Pikes Peak to Cayenne. This was from Colorado to Wyoming, and the link passed above Denver. So this is an important thing to mention because links above radio crowded places, they tend to suffer interference, and this is very nice. They managed to do this. We're gonna look at the video they made about it. I'm gonna play the video and I'm gonna comment as we go along. Just gonna put the sound here.
A new record. Wireless broadband link at 245 kilometers. At Cambium Networks, we continue to look for opportunities to push the limits of wireless broadband.
This is the Pikes Peak, location. As you can see, they used their devices, and this is a 3-foot parabolic dish antenna.
Challenged ourselves to set up the longest point-to-point link ever established in the world. We set it up quickly and used the connection to make a voice call and stream high-definition video. And we did it! 245.8 kilometers, just over 152 miles. We had two teams, one at a 14,000-foot elevation in Pikes Peak, Colorado, and the other 150 miles north near Cheyenne, Wyoming. And if that wasn't enough, we wanted to make it a little harder for ourselves by passing over a large metro center that has a high noise floor, Denver, Colorado. Each team had standard PT.
Okay, let's have a look here. This is their device. They have another. This is the feed of their antennas, which you can see over here. Two antennas, same size, I believe. They used two different models of radio transmitter and receiver. You're going to see just
and PTP 700 radios operating in the 5 gigahertz unlicensed spectrum, along with a Cambium gateway and an Axis network camera. The connectorized radios used 3-foot parabolic dishes. Link Planner software was used in advance.
Okay, let's have a look at this. Regulatory band. I see 1-5.8.
To plan the links.
Here we can see better. Okay, I believe this is channel 1 of 5.8, so it's the lower frequency of the 5 gigahertz band. They used their transmit power was 27, so it's normal for this kind of transmit. Here they have the receive power. I believe this is actually the receive signal. So they were receiving a signal of -66. This is a very good signal for 245 kilometers. So just continue. Here we have the bandwidth. They use the 45 megahertz bandwidth, and they use this the 16 QAM modulation. For the receive, they use this one. Link symmetry 1:1. And the range they actually have here, 245.
Site, the team was able to set up the equipment without any surprises in less than an hour. The voice quality from end to end was great. We connected the Cambium gateway router, and our team was able to speak with each other. Simultaneously, high-definition video.
So they set up an IP phone and an IP camera. So they were speaking to each other 245 kilometers ago over the wireless link.
Streamed between the locations using an Axis camera. Cambium Networks designs reliable, scalable products to maximize performance.
Let's go a bit backwards. This is what I wanted to show you. So they use two different models, as you can see, P2P 650 and P2P 700. As I mentioned before, these are point-to-point devices,
Reliable,
but they use different models.
Scalable products to maximize performance in all applications. We know how to connect places and connect them well.
Okay, let's check out if this link is it true. Let's check this out. So we have our favorite Earth curvature calculator here already opened. I'm just gonna open up this on this side. This is my link calculator from LIGO Wave. I've been misspelling this. LIGO Wave. Where were we? Okay, Pikes Peak altitude 4,293 meters above sea level. So at this height, when will you stop having line of sight? According to the calculator, you'll stop having line of sight at 233. Remember, this was at 245 kilometers, so it's you almost have line of sight. If you were at sea level, you almost have line of sight. You only need to be 9 meters above sea level to have line of sight when you start a link at this height. This is a very high mountain. So you hit the ground here at 233, but your link is 245, so it's like you're over here, have the link. So you need to be 5 meters above sea level. And the other place was, just going to show you here, 1,900 meters. So they had lots and lots of margin here. They needed to be 9 meters, they were 1,900. So at the end, the result looks like this, as you saw in the video. So it's a link with a very clear line of sight, and easy to make. I did a simulation with the 27 dBi antenna and 28 dBm of transmit power. They use the 27, so the difference here will be a bit different. I don't know the gain of that antenna. I believe that antenna has more gain than the 27 dBi I have here. For the results, this gives me, with this simulation, gives me a signal of minus 81. In the video, we could see they were receiving like minus 66. It's a huge difference between what I have here and what they have. The place here in Wyoming, Cayenne, I'm not sure this is the exactly same place where they put it, but so I searched for a place with altitude that could have a clear line of sight. So I'm short, about 3 kilometers short of the distance they made. But other than that, yes, there's no problem with this, not with the curvature or even with the hills, because the curvature could allow it, but you could have a mountain here in between and you wouldn't be able to make the link. So neither of these is a problem here. So this link is an amazing link, and I believe they've made it, and their technology, although the material looks very simple, it's capable of doing this kind of links over this distance. So thank you once again. I think this will be the last episode of this long distance, unless you know some others you want to put in the comments. If you know other long distance links you want me to comment, but at least one or some long range that you suspect that didn't happen. If we have the information about the approximate location, sometimes it's hard to get the exact location, but the approximate location, I can do a simulation and see if you can prove anything or not. But leave any comments if you want to. Thank you for watching. So see you next time. Subscribe, give it a thumbs up, share if you want to, and I see you in the next video. Thank you very much.